Now you have been listening to the discussion of this lesson, Unit 3 of the Grade 10 Science textbook. You have understood the discussion. Then I hope you read the lesson again and again until you were clear with the lesson. Then I want you to try all these questions first by yourself and then correct it with the discussion that I am going to do now. So when you listen to this discussion, you can check whether you have answered all the questions correctly. We will start off with the questions given in your textbook. The exercise. Complete the following sentences. The mass number of an element is 14. When we say mass number, you remember what that is. Each element, the atom, has an atomic number which is unique to the element and the mass number. The mass number of an element is 14 and its atomic number is 6. This atom contains dash number of electrons. So from this statement, you know that atomic number is equal to number of protons, which is equal to number of electrons. And the mass number is number of protons plus number of neutrons. So we need to find the number of electrons. That is equal to the atomic number. So the atom contains 6 electrons. The second one, an atom of an element consists of 19 protons, 19 electrons and 18 neutrons. The mass number of this atom. Mass number is what? It is the sum of protons and neutrons. So we have 19 protons and 18 neutrons. When you add them together, there will be 37 as the mass number. So the mass number of this atom is going to be 37. Why? We add up 19 protons and 18 neutrons. That is equal to 37. So 37 is the mass number. The sum of the number of protons and the number of neutrons in the nucleus of an atom is known as its, we have already discussed that, it's known as its mass number. So we have to write the word mass number. Mass number. So that completes these sentences. That is the first question. Now we will go on to the second question. The atomic number of aluminium is 13 and its mass number is 27. Write the atomic number and mass number of aluminium in the standard form. So to do this, you should know the standard symbol of aluminium. It is AL. A capital, L simple. Then you know the mass number has to go on top, atomic number has to go at the bottom and left of the element. So it will be 2730. The standard symbol of aluminium is 2713 Al. What is the number of neutrons in aluminium? To do this, we need to consider both the mass number and the atomic number. As you know, atomic number is equal to number of protons, that is equal to 13. And the mass number A is equal to protons plus neutrons. So we need to find neutrons. This is equal to 27. 7. If we subtract atomic number, that is number of protons, from mass number, proton plus neutron, we can find the value of neutrons. So, to find the value of neutron, you can subtract from mass number the atomic number. That is equal to 27 minus 13. So, the number of neutrons will be equal to 14. So, we can write that down again. Number of neutrons equals 14. So, you can remember this equation. Number of neutrons equals mass number minus atomic number. The third question. Complete the following table. They have given you the elements. We need to find the number of electrons in an atom, protons in an atom, and neutrons in an atom. Again, we have to consider the mass number and the atomic number. It's easy. Atomic number equals number of protons, which is again equal to number of electrons. And now you know the equation. Mass number minus atomic number will give you all the number of protons. So here number of electrons is equal to the atomic number 15. So we have 15 electrons, and the same for protons, 15 protons, and neutrons 31 minus 15. So we have 16 neutrons in a phosphorus atom, because phosphorus is 31, 15 phosphorus. Then we have 7, 3 lithium. Atomic number is 3, so number of electrons 3, number of protons 3, and the number of neutrons, mass number 7, mass number 7 minus atomic number, that is equal to 4. That is the number of neutrons. Then we have the third element, magnesium. 24, 12 magnesium. Atomic number is 12. So, what is the number of electrons in an atom? It has to be 12. What is the number of protons? Yes, 12 again. And here, what is the number of neutrons? We have to subtract 12 from 24. That is also equal to 12. Calcium. 40, 20 calcium. Atomic number equals the number of protons and electrons. So, that's equal to 20. 20 electrons, 20 protons, and we have 40 as the mass number. So, the number of neutrons have to be 40 minus 20, that is equal to 20. The last example, we have chlorine. 35, 17 chlorine. 17 is the atomic number of chlorine. So, we have 17 electrons and 17 protons. And since the mass number is 35, 35 minus 17 will give you all the number of neutrons. 35 minus 17, that is equal to 80. So, that is the number of neutrons in chlorine. We have filled up this table. We will get on to the next question. Write the chemical formulae of the following compounds. Remember, students, how we write the chemical formulae? You need to write down the standard symbols of the atoms of that compound first. Then you write the valencies. exchange the valencies, and finally you write the chemical formulae. When you write the chemical formula, if one particular atom gets the value 1, then we don't have to write it in the formula. The same way, when there is a chemical formula where both atoms, if there are only 2 types of atoms, if both atoms get the same value, then also we don't need to write the values. So we will write the chemical formulae for these compounds. Lithium fluoride. So here we have to write the lithium first from the name, and then fluoride means it's fluorine element. Lithium belongs to which group? Yes, group 1. So valency 1. Lithium is 1 and fluorine belongs to group 7. Again valency 1. So we exchange the valencies and we get LiF. We don't have to write the 1 and 1 again. Beryllium chloride. The standard symbol for beryllium, yes, it's Be, and chloride means from chlorine element. So Cl. Beryllium belongs to group 2. So the valency is 2. Chlorine belongs to group 7. Valency 1. When we exchange the valencies, it becomes Be1Cl2. So we don't have to show the 1 in the formula. Therefore, we can rewrite the formula as BeCl2. Beryllium chloride. Then we have aluminium oxide. You have done this already. The symbol for aluminium is Al. Oxide is oxygen. And the valencies you have written 3 and 2. And when we exchange the valencies Al2 and O3, I will write the formula here. Al2O3. That is the chemical formula of aluminium oxide. Al2O3. Then the 5th question. Write the chemical formulae of the following compounds. Here again, we can exchange the valencies and rewrite the compound. If you have already practiced well, then you can directly write the chemical formulae of these compounds. And also, you can see that there are polyatomic ions or radicals involved in these different compounds. We will write the formulae one by one. I will start with the first compound, ammonium chloride. So, you can remember the chemical formula of ammonium ion. Yes, it is NH4 plus and chloride is Cl atom or Cl minus ion. If we look at the valencies, NH4 plus has 1 valency, Cl has 1 valency. You exchange the valencies, both are equal and they are equal to 1. Therefore, we can directly write it as NH4Cl. We do not need to write the 1. Second one, calcium hydroxide. Calcium is Ca and hydroxide is OH minus. So the valencies, calcium has 2, OH minus is minus 1, so 1. And when we exchange the valency, we get calcium 1 and for OH we have to put 2. It's more than 1. Then what do we do, students? We have to put it in parentheses and then write the 2 there. And also we don't need to show the 1. Therefore, I can rewrite it as CaOH twice. That is the chemical formula of calcium hydroxide. The last one, calcium phosphate. Calcium phosphate is calcium is Ca, phosphate is PO4 and 3 minus. So if we write the valencies, calcium 2, phosphate 3, and you have to exchange the valencies, you will get the formula Ca3 within parentheses PO4 twice. I will rewrite the formula again to show it more clearly. Ca3 PO4 twice. Since we have PO4 is a radical and more than one PO4 radicals, we write it in parentheses and write the 2 there. Calcium phosphate. We'll go on to the next slide with more examples. Magnesium sulphate. You know the symbol for magnesium, Mg, and sulphate is a radical, SO4 2 minus. And if you take the valencies, both are equal, 2 and 2, you have to exchange it. It will become MgSO4. You don't have to write the 2. So therefore, we can, this becomes 2. This also is 2. So we can leave these out and write it as MgSO4. That is the formula of magnesium sulphate. Then we have aluminium nitrate. Aluminium Al, nitrate NO3 minus. Aluminium, what is the valency, students? You have already done this question. Yes, you know it is 3. NO3 minus, it's 1. So what did you do? You exchange the valencies and you got the value as Al. Here, since it's a radical which is more than 1, we have to write it in parentheses. You have done it correctly. AlNO3 thrice. So you can see, students, when we say out the names, when it is a radical that is occurring more than once or more than 1 radicals are present, then we say twice or thrice. We don't say 2 or 3. That is a convention. AlNO3 thrice. That's how we say it. Potassium permanganate. Potassium, what is the symbol? Yes, it is K, and permanganate, you can remember the radical, MnO4 minus. MnO4 minus. And the valencies, potassium has 1, MnO4 minus is 1. And when you exchange the valency, both are equal and equal to 1. So what is the formula you have written? KMnO4. That is potassium permanganate. We'll go to the next one. Calcium chromate. Calcium is Ca, you can remember. Chromate is CrO4 2 minus. So if we write the valencies 2 and 2, that you have done it, and we exchange it. So what did you get? You get calcium CrO4 because both are equal values 2 and 2. We don't have to write it. CaCrO4 is the formula for calcium chromate. Next we have ammonium dichromate. Both are radicals or molecular ions. Ammonium, what is it? NH4 plus. Dichromate is Cr2O7 2 minus. So what are their valencies? Ammonium 1, dichromate 2. 1 and 2. And when we exchange the valencies, you will have to write NH4 2 times. So you have to write NH4 in parenthesis. NH4 twice, Cr2O7, but that's going to be only 1. So we don't have to write parenthesis and also we don't have to write the 1. NH4 twice, Cr2O7. Then we have sodium hydrogen carbonate or sodium bicarbonate. Sodium, you know, is Na, and hydrogen carbonate or bicarbonate is HCO3 minus. So that's the formula of bicarbonate. Both the valencies are equal and it's equal to 1. So when you exchange the valencies, you get the formula as NaHCO3. This is the formula for sodium hydrogen carbonate or sodium bicarbonate. We will look at the next questions. Potassium carbonate. Potassium again, the symbol is K and carbonate is CO3 2 minus. Yes, CO3 2 minus. Then the valencies 1 and 2. And we have to exchange the valencies. The formula becomes K2CO3. That is the chemical formula of potassium carbonate. Now we will do the next question. What valencies should the following elements have? Students, to identify the valencies, you have to remember the atomic number. You can memorize the valencies, that's fine. But if you haven't memorized the valencies, don't worry. You know the order of the first 20 elements. That is something you have to remember. Then what do? We write the atomic number from the order. Say if it is the third element in order, you know the atomic number is 3. Then from that, you can write the electronic configuration and the number of electrons in the valence shell will be relevant to the group number. From the group number, you can find the valency. And you all know across the period from left to right, the valency changes as 1, 2, 3, 4, 3, 2, 1 and 0. If you remember that, you can easily write down the valencies. So we'll do these examples. First one is lithium. So as I said, if you can remember the atomic number of lithium, hydrogen, helium, lithium. Yes, atomic number 3. So if you can even write the electronic configuration, I'm just doing one example in detail so that you can relate all what you have learned before. So we have the electronic configuration 2, 1. Then what group does lithium belong to? Group 1. So what is the valency? Group 1 has valency 1. That's very easy. Then we have carbon. carbon belongs to group 4. So again, to remember, carbon has atomic number 6. 2, 4 is the electronic configuration. So it belongs to group 4, valency 4. Then we have calcium. If you can remember the order of elements, calcium is the last element out of the first 20. So it has atomic number 20. And the electronic configuration 2882. Since it has valence electrons 2, it belongs to group 2 and the valency is also 2. Valency 2. The next example, sulfur. Sulfur, if you can remember the position, it belongs to period 3, group 6. Because sulfur has atomic number 16. 2, 8, 6. So group 6. And you can remember there are few elements that have more than one valencies, and sulfur is one of them. It has 2 valencies. One is 6, the group number itself, and group 6 is 8 minus 6 valency, that is equal to 2. So it has another valency 2. Sulfur has 2 valencies. Then we have chlorine. Chlorine, if you can remember, atomic number 17. Therefore, the electronic configuration is 287. It belongs to group 7. And chlorine is also another element that has 2 valencies. So here we can write the valency as 1 is the group number 7, and you can remember group 7 is 8 minus 7, valency 1. So it has valency 1. So in this, sulfur has 6 and 2, 2 valencies, and chlorine has 7 and 1, 2 valencies. So we will go on to the next question. A part of the periodic table is shown below. The symbols given in it are not true symbols of the respective elements. Answer the questions below that are based on them. So when you get a question like this, students, first you have to relate these symbols to the correct elements. For example, if we take A, you can see it is in group 4, period 2. So you can identify the element as what? Yes, as carbon. So for convenience, what we can do is we can write down the elements there, either from the position or by remembering the order. So here we know this is carbon. Then we know this is neon. Why? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and we have chlorine. Then we have argon, potassium, and calcium there. After identifying the elements, it's easy to answer the questions. But remember, when answering the questions, you have to use the given symbols. Always remember that. I will write it here. Answer the questions using the given symbol. The given symbols. Usually they write that in the question, and by mistake, instead of giving the answer as A, if you write the answer as C, because you know that it is carbon, then you will not get the marks. So remember students, when you get a question like this and they say the symbols given in it are not true symbols of these respective elements, answer the questions below that are based on them. You have to answer the questions using the given symbol. Now we will go to the questions. Identify the element or elements that behave as noble gas. Mass number of Y is 35. Find the number of protons and neutrons in an atom of Y. Write the electronic configuration of R. How many valencies are shown by A? A compound is formed by the reaction between A and Y. Write the probable formula of this compound. Name two metallic elements. Now we will answer the questions one by one. Identify the element or elements that behave as noble gases. We already identified the elements. D and E, you can see here, they belong to group 8. So these are the noble gases. Remember, you have to write the symbols given to you. So you have to write it as D and E. Those are the noble gases. Then we'll go to the next question. Mass number of Y is 35. Find the number of protons and neutrons in an atom of Y. So they have already given us the mass number A, that is equal to number of neutrons plus protons, and is equal to 35. This is the data given to us. And we need to find the number of protons and neutrons. So to do that, we need to know the atomic number. Since we have the periodic table given to us, we can identify the position of Y. Here, Y is here. You can directly count the position starting from 1, or you know Y is in group 7, period 3. So it has to be chlorine. We have already identified it. And the atomic number of chlorine is 17. Either you can count it up to 17, or since we have identified the element, you can remember the atomic number as 17. So Z is atomic number, that is equal to protons and electrons, and that is 17. So we need to find the number of protons. From this, you can find protons equals atomic number 17. And the number of neutrons is mass number minus atomic number that we have done before. Mass number is A minus atomic number, that is equal to 35 minus 17. We have 18 neutrons. So in an atom of Y, there are 17 protons and 18 neutrons. Now we will go on to the next one. Write the electronic configuration of R. R is here. We identified it as calcium, and you know the atomic number of calcium, 20. In case you forget, you can also count the number starting from hydrogen up to calcium. So R has atomic number 20. Remember to use the symbol given to you. And when we write the electronic configuration, it will be 2, 8, then it's 10, another 8, 18. Therefore, we need to have 2 more. 2, 8, 8, 2. And here, students, you have to remember the shell that has the electrons. If it is the outermost shell, it cannot have more than 8. That is the reason, although there can be a maximum of 18 electrons in the third shell, we put the last 2 electrons to the fourth shell. So this is the electronic configuration of R, 2882. Then the next part, how many valencies are shown by A? We have identified A as carbon, and if you remember, there is only one valency because carbon shows valency 4. Here they have asked how many valencies. So we have to write A shows 1 valency. They haven't asked what, they have asked how many. So it shows only 1 valency. The next part, a compound is formed by the reaction between A and Y. Write the probable formula of this compound. So to do that, we need to know the valencies of atoms A and Y. So I'll write the symbols as A and Y. Since they have given it in this order, I have written it in the same order, A and Y. And then we will try to identify the atoms and their valencies. A is this, it was identified as carbon, and also you can see group 1, 2, 3, 4. Since it is in group 4, the valency is 4. 5, 6, 7. Here the group number is group 7. So if I write down the valency values, this will have valency 4. Whereas Y will have 2 valencies, that is 7 and 1. Out of that, for us, we normally use valency as 1. Group number minus the number of valence electrons. That's 1. So we will take the valency as 1 and 4. Then we can write the chemical formula for the compound. A valency 4 and Y valency 1. We need to exchange the valencies. Then you will get the formula as A1 Y4. And you know, you don't have to write this 1. So I will rewrite the formula as AY4. That is the chemical formula of the compound formed between A and Y. So this is how you have to write, and make sure that you use the given symbols. If you wrote this as CCl4, then it will be wrong because they have given these symbols. So this is why you need to use the given symbols. So this is something that you have to remember, students. Unless they specify and specifically ask, write the formula in their true symbols, you have to use the given symbols. Name two metallic elements. From the periodic table, you all know the first two groups are metals. Group 3, aluminium, is a metal, and thereafter we have the non-metals. So, in this periodic table, they have given Z in group 1 and R in group 2. And also, we identified them as sodium and calcium. So, they are the metals. We have to write the given symbols. Metals are Z and R. You can also just write it as Z, R or Z and R. That's more than enough. Question number 8. D, E, G, J, L, M, Q, R and T are 9 consecutive elements in the periodic table. So here they are consecutive elements. That means they are there in the periodic table one after the other. But they can be in the same period or they can belong to different periods. R is a noble gas belonging to period 3. That is the important information. R is a noble gas. That means it is present in group 8, period 3. So, if it is group 8 and period 3, that means it has to be argon. Yes, you have identified the element as argon. So, T has to be the element after that, and elements from D to Q are elements before that. So, we will have to identify these elements, then it will be convenient to answer these questions. I will write these elements down: D, E, G, J, L, M, Q, R, T. Those are the elements. And we have identified R as argon. So, here you can see R is argon. If we consider the order of elements in the periodic table, you can remember after argon, it has to be potassium. So, T is potassium. And before argon, if we write down the elements, Q has to be chlorine, M sulfur, L phosphorus, whereas J is silicon, G aluminium, E magnesium, and D has to be sodium. If you write this down, students, you may not be using the real symbols, but it will be easy for you to relate these properties and answer the questions so that you will not make any mistakes. Now we'll go to the questions. Of these elements, identify the two elements belonging to the same group. Here you can see immediately sodium and potassium belong to the same group. Like that, it will be easy for you to answer the questions. To which group of the periodic table do those elements belong? Of the above, name the element of highest electronegativity. Write the formula of the compound formed by the reaction between E and M. Of the above, identify the element with 4 valence electrons and write its electronic configuration. Of the above, name the element with the highest first ionization energy. Now, we will answer these questions. I hope you have already written the answers so that you can check the answers while I discuss them. Here is a table of elements that we already identified in the previous slide. So, the first question, of these elements, identify the two elements belonging to the same group. Now that you are very familiar with the periodic table, you know the elements sodium and potassium belong to the same group. So that means those are the elements in the same group. But we have to use the given symbol. So of these elements, two elements belonging to the same group, we can write the answer as D and T. Those are the elements that belong to the same group. The next one, to which group of the periodic table do these elements belong to? We identified sodium and potassium as belonging to the same group, and you know the group of these two elements. Yes, it is group 1. So you have to say group, and 1 has to be written in Roman numbers. Group 1. Of the above, name the element of highest electronegativity. You can remember, students, what electronegativity is? Yes, it is the ability to attract electrons towards itself from a covalent bond. And the elements that have the highest electronegativity belong to what group? Yes, they belong to group 7. Group 8 is not considered for electronegativity, and across the period from left to right, electronegativity increases. And group 7 has the highest electronegativity. So we need to find the element that belongs to group 7. Here it is chlorine. Because it's one period, potassium is in the next period, we take the element that belongs to group 7. Okay, this is in group 7. So we have to write its given symbol Q. So the element with the highest electronegativity is Q. That is the element with the highest electronegativity. Write the formula of the compound formed by the reaction between E and M. So first we should know what E and M are and find their valencies. We have identified E as magnesium. So the valency of magnesium is known to you, it's 2. The same sulfur also has the same valency 2. So now we can write the chemical formula. Here also we have to use the given symbols. So we have E, we have M, and the valencies are 2 and 2. We exchange the valency. So you will get E2, M2. Do we leave it like this? No. We have to remove the 2 and rewrite the formula. So it will become EM. That will be the chemical formula of the compound formed between elements E and M. The next part, of the above, identify the element with 4 valence electrons and write its electronic configuration. So 4 valence electrons means it has to belong to group 4. Out of these, silicon belongs to group 4. That means we need to write the electronic configuration for element J. You can remember the position of silicon in the periodic table. So therefore, you can remember the atomic number. So J has atomic number 14. I will write it as part of the standard symbol, atomic number 14. So we can write the electronic configuration easily. This will be 2, then there has to be 8, 10 electrons, and the last shell will have the last 4 electrons. 2, 8, 4. If you add them together, 10, 14, and you can see 3 energy levels containing electrons. So it is in period 3 and 4 electrons in the valence shell, group 4. So J is silicon, therefore it will have the electronic configuration like this, 2, 8, 4. The last part of the question, of the above, name the element with highest first ionization energy. Can you remember the first ionization energy graph? Try to recollect it. The first ionization energy decreases down the group because the size increases. At the same time, it increases according to a pattern along the period from left to right. So you get a zigzag graph. And in that, always group 8 elements or group 0 elements come at the top of the graph, because the group 8 elements have the highest first ionization energy in a period. So, of the above, name the element with the highest first ionization energy. We have to find the element that is in group 8. Out of these elements, if you look at argon, that is the noble gas. So this belongs to group 8. Therefore, R is the element that has the highest first ionization energy. So we will write element R. Or you can just write it as R. So with this, we have finished the questions given in your textbook. So students, I hope before looking at this discussion, you tried the questions first and then you corrected it while looking at the discussion. So with that, you would have got a better understanding of the lesson. We will not stop here. We will discuss some more additional questions. The first question, nuclei of different atoms are given below. So here you can see there are different atoms, their nuclei are shown. So in the nuclei or the nucleus of an atom, you can see there are protons. The protons are denoted by shaded circles and the neutrons are denoted by normal empty circles. So from this diagram, you can see there are different types of nuclei with different number of protons and neutrons. So based on that, we will answer these questions. Which of the above atoms have the atomic number 3? Which of the above atoms have the mass number 6? So already you have learned atomic number and mass number. Atomic number means the number of protons. They are equal to the number of electrons, but because the number of electrons can change, we always stick to the number of protons. So, from each atom, we can identify the atomic number. Then, for the mass number, we need to add the number of protons and the number of neutrons together. Why? They are the subatomic particles that have a mass compared to the electrons. Which of the above atoms are isotopes? As you already know, isotopes are the atoms of the same element with different mass numbers because the number of neutrons are different. Then we have the fourth part, write the standard symbol of atom D showing its atomic number and mass number. That is the basic standard representation of an atom where you write the atomic number and the mass number with the symbol of the element. So now we will answer these questions. Which of the above atoms have the atomic number 3? So we need to find the atomic number. Atomic number is what? The number of protons present in an atom. So if we look at this picture, you can see the different nuclei and the number of protons present. In the first one, there is only one proton because there is only one shaded circle. Then B, atom B has 2 protons. So atomic number 2. Atom C has 3 protons. So it's a different atom with atomic number 3. Then in atom D, there are 2, 4, 6 protons. So that's atomic number 6. Again, if we take atom E, 2, 4, 6. That also has 6 protons. So there are 2 nuclei with the same atomic number, 6. So that means they belong to the same element. But the other 3 are different from the last 2 nuclei. So to answer the first question, atomic number 3. So that is this nuclei. So atom C has atomic number 3. So to answer this question, it is atom C with atomic number 3. The second question, which of the above atoms have the mass number 6? So to identify mass number, we need to add the protons and the neutrons together. So here we have atom A with, if we look at the picture, atom A has 1 proton and 2 neutrons. So when we add that together, we get the mass number as 3. Whereas atom B also has 1 neutron and 2 protons. So there again the mass number is 3. If we take the third atom, that is atom C, there are 6 particles in the nucleus. 3 protons and 3 neutrons. So that again the mass number will be 6. If we go to atom D, there are many. And obviously, because there are already 6 protons, the mass number is higher. So we need to find the atom that has the mass number 6. So here from the calculation, we have found that atom C has mass number 6. So the same answer, atom C has mass number 6. Third one, which of the above atoms are isotopes? So you know the definition for isotopes. These are atoms of the same element with different mass numbers. We have already found that both atom D and atom E have the same atomic number. Atomic number is a unique property for an element. So they both belong to the same element. Now we have to check whether they have different mass numbers. So if I calculate the total number of particles, there are 6 protons in D and there are 6 neutrons in D. So that means D has altogether 12 particles in the nucleus. 6 protons and 6 neutrons. So this has a mass number 12. But if we count, I have already counted this 1, 2, 3, 4, 5, 6. 6 and 6 protons, 12 in the nucleus. So therefore, the mass number is 12. If I count for the atom E, there is 1, 2, 3, 4, 5, 6, 7 neutrons in the nucleus. So 6 protons and 7 neutrons together, it gives mass number 13. So here you can see both the atoms have atomic number 6 but different mass numbers. So therefore, these two elements become the isotopes. Atoms of the same element with different mass numbers. So if I answer the third question, which of the above atoms are isotopes? Those are atom D and E. The two atoms that are isotopes. Write the standard symbol of atom D showing its atomic number and mass number. We have already found the atomic number and the mass number for atom D. And students, since they have asked the question as atom D, even though you have identified that atom, what is that element? Yes, that is carbon. You already know carbon has atomic number 6. You would have already identified that 12,6 is carbon. But you should not write carbon here. You have to use the symbol that is given to you. So to write the standard symbol, we will write it as D. And what do we write? We have to write the mass number on the top left side of the symbol. So that is 12 and the atomic number below on the left side. So 12,6 D is the standard symbol for this element. We'll go to the next question. Statements about a few elements of the periodic table are given below. So these are the elements Q, R, S, T, U and V are not the standard symbols of elements. Identify the elements Q, R, S, T, U and V. For your convenience, a periodic table is given to you. So the first statement says noble gas Q is present in the third period. So as they say noble gas, you know it has to belong to group 8 or group 0. So if it is group 8 or group 0, you can see we have the first element that will be helium. Then we have the next element that is going to be neon and finally argon with atomic number 18. So here they say Q is a noble gas belonging to the third period. So that means it has to be this particular element and that has to be Q. So again, we don't use the real symbol. We have to use the symbol given. but they have asked you to identify the elements Q, R, S, T, U and V. So here Q has to be equal to or I shall write it as Q is argon. In brackets, if I write, this is argon. When you answer the question, you can just directly write it as Ar or argon. But here, for you all to understand and practice, I am writing a complete answer. Element R contains 7 valence electrons and is present in the second period. So, when they say 7 valence electrons, you all know the number of valence electrons is equal to the group number of the element. So, this element R has to belong to group 7 and it says it belongs to period 2, second period. So, if we go to the periodic table here, group 7 second period will be this. That is going to be fluorine. Fluorine is the element that is there in group 7 period 2. So, here the answer for this question, element R contains 7 valence electrons and is present in the second period. It is fluorine, F. So, if you want, you can just leave the symbol or you can write it as fluorine. Element S contains electrons in 4 energy levels and has the lowest first ionization energy. So, when they say 4 energy levels, what is the relationship between energy levels and position in the period? The number of energy levels is equal to the period to which the element belongs to. So, this element obviously belongs to the 4th period. Out of the 2 elements, potassium and calcium, always group 1 has the lowest first ionization energy. Or if you can remember, the ionization energy starts from group 1 and increases along the period from left to right according to a certain pattern. So, the element that has the lowest first ionization energy has to be this particular element. That will be potassium. So, to answer this question, K is the symbol for potassium. If you can write the name as well, potassium is the element. Element T is present in period 3 and forms T2 plus ions. So, any element that can be present in period 3, starting from atomic number 11 to atomic number 18. Now, you remember all the elements in order. It starts with sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Out of these, if you take the first few elements which are metals, they are the ones who normally form 2 plus or plus ions. And out of that, if it has to be 2 plus, then it should belong to group 2. Why? The group 2 elements have 2 valence electrons and it is easy for that particular element to lose 2 electrons easily. So, therefore, the element that belongs to period 3 and forms 2 plus ions is here. If we take that element, that will be magnesium. So, we have identified element T, that is magnesium. Mg is magnesium. Then we have element U. Element U is a yellow color crystalline solid present in the third period. So, if you take the third period, we have discussed some metals and non-metals belonging to the first 20 elements. And out of that, if you can remember something that has yellow color crystalline nature. What is it? It is sulfur. Sulfur is a non-metal that exists as allotropic forms. There are two forms. One is the yellow color crystalline solid. The other one is the white color amorphous powder. So here sulfur is present in the third period. If you look at the position of sulfur, it is present in group 6 and period 3. So, sulfur is the element that has a yellow color crystalline solid form. So, this is S sulfur. So, now we have identified all the elements. These are elements starting from argon. Q is argon. Then we had fluorine, potassium, magnesium and sulfur. So, from the properties we can identify elements. Now, we'll get on to the next question. Some metals, non-metals and metalloids are given below. Sodium, magnesium, carbon, hydrogen, nitrogen, oxygen, sulfur, silicon, aluminium. Write the elements that form acidic, basic and amphoteric oxide in order. You can remember, students, we discussed the acidic, basic, amphoteric properties of oxides of the third period of elements. So, their metals usually form basic oxides. Then we had aluminium, which forms amphoteric oxide, and starting from nitrogen, we have all acidic oxide. So, here we have many different elements. Out of these, the ones that form acidic oxides are all non-metals. So, if I write the elements that form acidic oxides, you can see the first elements, sodium and magnesium, they are metals. So, they form basic oxide. Then carbon forms acidic oxide. H2O is the oxide of hydrogen, that's water, that's neutral. Again, nitrogen is a non-metal that forms acidic oxide. Oxygen. Oxygen itself is the element that does not form oxides. Then we have sulfur. Sulfur forms two types of oxides, sulfur dioxide and sulfur trioxide, which you know is a very strong acidic oxide. This causes acid rain. So, sulfur also forms acidic oxide. Silicon, SiO2 is the oxide of silicon. That is a very weak acid, but still we consider it as an acidic oxide. So, silicon also forms acidic oxide. Now, we have identified all the acidic oxides. Then we will write down the basic oxides. If we write the basic oxides, these are the oxides of metals. So, out of these, the elements that are left out are sodium, magnesium and aluminium. Sodium and magnesium, they form basic oxides. But aluminium, although it's a metal, it forms amphoteric oxide. So for basic oxide, it's sodium and magnesium. But we need to include aluminium. Aluminium forms amphoteric oxide. So those are the different types of oxides formed by these elements. Then we go to the next question. What is the element that doesn't react with cool water but reacts with steam? We have done a few activities with metals, reactions of metals with water. In that, when we put a small piece of sodium, it reacts very vigorously with water. Whereas magnesium, it does not react with cool water, but it reacts with both hot water and steam. So the answer for this question, what is the element that doesn't react with cool water but reacts with steam? So that is magnesium. One element or one metal that reacts with steam but not with cool water. State the element that burns in air with a blue color flame. We have carried out this activity in the lab. You have observed the change, the blue color flame. What is it? Yes, it is sulfur. Sulfur is a non-metal that burns with a blue color flame. So, element that burns in air with blue color flame is sulfur, S. What is the element used in the production of electronic devices? Electronic devices, it has to be a semiconductor. Semi means partially conducting ability. So, metals are good conductors, non-metals are not conductors of electricity, whereas the metalloids can conduct electricity well under certain conditions. So, these become very useful in the production of electronic devices. So, what is the metalloid here? Silicon. Yes. So, silicon is the element that is very useful in the production of electronic devices. So, those are the elements relevant to these questions. Now, we will get on to the next one. Additional question 4. The variation of electronegativity of 6 consecutive elements of the second and third periods is shown in the graph given below. So, you can see these are 6 consecutive elements. That means they have atomic numbers in order, or they are there one after the other in the periodic table, and they belong to the second and the third periods. So, if you look at the graph, students, you can identify from element D to element E, there is a drop in electronegativity. That means the elements move from the second period to the third period. If you can remember, electronegativity increases along the period from left to right. So, in this graph, you can observe A, B, C and D, the values increase. And from D to E, there is a large drop. So, that means it is the next period. So, elements E and F are present in the third period of the periodic table. So, those are the information that you can obtain from this electronegativity graph. And here you know the two axes. The x-axis has to be the atomic number, but it is not given to you because you need to identify the elements. And the y-axis is the electronegativity. So you don't have to label the axis, but if you know what they are, then it is easy to identify the elements. The questions. There is an element between elements D and E in the periodic table. What is that element? Identify the element from above that is very commonly used in nanotechnology. To what group does element B belong to? Identify the metals from above. There are different methods of expressing electronegativity. Write the name of the scale that you learn. How does the electronegativity of elements vary from left to right along the period? Write the formula of the compound formed between D and F. So these are the questions. You all answer the question first and then listen to my explanation. Now I will move on to the first question. There is an element between elements D and E in the periodic table. What is that element? So here we already identified that from D, when it goes to element E, that means the elements change from period 2, that is element D is in period 2 and element E is in period 3. If you can remember the order, I am sure you do, you know that the first element in period 3 is sodium. So, E is sodium. But the previous period, you can remember students, group 8 elements are noble gases. Why? Because they don't form bonds. And if they don't form bonds or compounds, that means they don't have an electronegativity value. So the element that is missing here is the group 8 element. And so before that, it is element D. So that should be present in group 7. So here D has to be in group 7. And what is that element? It is fluorine because it is the second period, group 7. So here we have fluorine, then we have sodium there. And I am sure you know the elements in order from 1 to 20, and the element that belongs to group 8 and that is missing in this graph is neon. So here there is an element between elements D and E in the periodic table. What is that element? It is neon. I'll write the name as well. It's neon. Identify the element from above that is very commonly used in nanotechnology. Here you can see we identified this as group 7. So C will be group 6, B will be group 5 and A will be group 4. If you can remember students, in nanotechnology they use nanomaterials and carbon is one of the most commonly used nanomaterials and carbon belongs to group 4 period 2. That means element A is carbon. So here identify the element from above that is very commonly used in nanotechnology. You have to write it as element A. To what group does element B belong to? We have already identified that. That is group 5. Identify the metals from above. So, as you can see here, group 4, 5, 6, 7, they are all non-metals. Then we have E, that is group 1, sodium. So, obviously, F is in group 2 and that will be magnesium. Sodium and magnesium are metals. So, identify the metals from above. It will be elements E and F. I'll move on to the next question. There are different methods of expressing electronegativity. Write the name of the scale that you learn. I'm sure you know the name of the scale. It is Pauling's scale. So here the answer is Pauling's scale. How does the electronegativity of elements vary from left to right along the period? So what is happening to the electronegativity here? When you go from left to right across the period or along the period, the electronegativity increases. So here we have to say it increases. Or we can say electronegativity increases across the period from left to right. Write the formula of the compound formed between D and F. So here we already identified element D is in group 7. And you can see element F. F is in group 2. So D is a non-metal and F is a metal. When we write chemical formulas, we have to write the metal first. So here I write it as F first and then D. Then what do we do next? We have to write the valency of the elements. F is in group 2, so valency 2. And D is in group 7. What is the valency? 1. So here it's 1. Then we exchange the valency value. You will get it as F1, D2. Do we need to write this F1? No. So we can rewrite the formula as FD2. So that is the formula of the compound formed between D and F. That is the end of this question. Let us move on to the next question. Statements regarding elements magnesium, chlorine, carbon and neon are given below. So these are statements related to the elements. We will try to identify the elements first. Burns with a bright white flame in air. So as you hear this word, bright white flame, you have seen metals being burned, non-metals being burned in air. So here it burns with a bright white flame. So you know it has to be out of these four, it has to be magnesium. That is the strip that burns with a bright white flame. exist as allotropic forms in nature. You have learned a few elements that exist as allotropic forms, and out of those, what is the element here that has allotropic forms? It's carbon. It has many different allotropic forms. So, carbon is the element that has many different allotropic forms. Can be used as bleaching agent and used to clean swimming pools. An element that can be used as a bleaching agent and is used to clean swimming pools. This is something that you have known in general. It is chlorine. Normally, the water we get to our households are also purified by the addition of chlorine. So, chlorine is the element that is used to clean swimming pools, and also it can be used as a bleaching agent to get rid of the colors. You can use chlorine, or stains. To remove stains, you can use chlorine. Used to fill filament bulbs. An element that should not react with the filament should be used to fill the bulb. So, that is element that is a noble gas. You can either use a noble gas or you can also use nitrogen gas. But in the elements given to us, we don't have nitrogen. We have neon, and you have heard of neon bulbs. So, neon is the element that can be used to fill filament bulbs. With those identifications, we will answer the questions. Identify the elements suitable for each statement. We have already done that, but to answer the question, I will write the statement number and the element. So, A is magnesium, B is carbon, C is chlorine, and D is neon. We have already identified the elements. Write the word equations for the reaction of magnesium with steam and hot water. You know, magnesium reacts with steam and hot water but does not react with cool water. So, to write the word equation, magnesium plus water, that is hot water, will give magnesium hydroxide and evolve hydrogen gas. That is the reaction of magnesium with hot water. It produces magnesium hydroxide and evolves hydrogen gas. But when magnesium reacts with steam, so here magnesium with steam. If you have written it as a chemical equation, then you have to show it as H2O gas. But here we can write it as steam. So, this does not produce magnesium hydroxide. Instead, magnesium oxide is produced. So, here the difference is there is magnesium oxide. And hydrogen gas. So, in both reactions, the reactants are the same: magnesium, hot water, magnesium, steam. Because they are at different physical states and different temperatures. More heat is there in steam. The products are different. With hot water, magnesium hydroxide and hydrogen. With steam, magnesium oxide and hydrogen. Then what is the element that exists as a monoatomic gas in nature? Normally, the group 8 elements, they don't react with other elements. They don't form homoatomic molecules. So, they exist as monoatomic gases. One atom itself becomes the gas, monoatomic gases. Out of these, neon is the only noble gas. So, this exists as the monoatomic gas. Question 6. Some elements are shown in the periodic table below. Given below are not the standard symbols of the element. You have to remember this. Are not the standard symbols of the element. But for convenience, as you look at a question like this, if you can identify the elements first, then it will be easy for you to answer the questions. You remember the first 20 elements in order. So, hydrogen, helium, lithium, beryllium, boron. Already carbon is given as C. Nitrogen, but oxygen is shown as F. Then here we have fluorine and A will be neon. B is going to be sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and D will be chlorine. D will be element chlorine. And we have after chlorine, argon, potassium, and E will be calcium. So, you have already identified the elements. You will not need to write the correct symbols. You have to answer the questions using the symbols given to you. But for convenience, we identify the elements. Here you can see the questions. Write the electronic configuration of element D. Write the element that exists as a solid in room temperature. Write the element that forms diatomic molecules. Write the element that reacts vigorously with water and forms a compound that turns red litmus paper to blue. Write the formula of the compound formed between D and E. Some elements exist as isotopes. What are isotopes? What is the element denoted as D in the periodic table given above? Write the standard symbol of the isotope of element D with 18 neutrons. Now, we have already identified the elements. You know the questions. You have already tried to answer the questions. We will discuss the answers. Write the electronic configuration of element D. We can see element D is in group 7, period 3. So, from that itself, you can easily write the electronic configuration. If it has to belong to group period 3, it should have the first 2 shells completely filled. So, it has to be 2, 8, and since it belongs to group 7, it has to have 7 electrons in the last shell. So, the electronic configuration will be 2, 8, 7. Very easy. Identify the position. Accordingly, write the electronic configuration. Write the element that exists as a solid in room temperature. Out of these, you can see already we have C. C is carbon that we identified as a solid. Then F is oxygen. We have A, that is a noble gas, neon. And D is also a gas, it's chlorine. So these are all gases. But these three, C, B and E, are all elements that exist as solid at room temperature, because B and E are metals, sodium and calcium. C is carbon. You can write any one of those elements. Here they have asked the element that exists as solid in room temperature. Normally, you will have to write only one element. Here, for your practice, I am writing all three. You can write any one. You can write C, or you can write B, or you can write E. All these three are solids at room temperature. Write the element that forms diatomic molecules. Diatomic molecules are either formed by hydrogen, H2 gas, O2, N2 and group 7, F2 and Cl2. These are the diatomic gases. Out of those, we have both F and D. F is oxygen and D is chlorine. So both of them form diatomic gases. Write the element that forms diatomic molecules. So here you can either write F or you can write D. So again, when you are answering, you can just write one element. But here, since you are practicing, I have written both the elements. That's why or. You have to just write one element. Write the element that reacts vigorously with water and forms a compound that turns red litmus paper to blue. Out of the activities we did, you can remember very well, sodium reacts vigorously with water and it forms sodium hydroxide, which is a base, and bases turn red litmus paper to blue. So here B element is sodium. So you have to write element B. That is the element that reacts vigorously with water and forms a compound that turns red litmus paper to blue. Write the formula of the compound formed between D and E. So as I said before, D and E, we know the groups. You can see it from the periodic table. E is a metal and it belongs to group 2. Therefore, the valency will be 2. And D, as you can see, it belongs to group 7. So, the valency is 1. Group number is subtracted from 8. 8 minus 7, valency 1. So, what do we do now? We have to write the elements in order. Normally, we write the metal first. So, we have to write element E first. Then we have to write element D. Then we need to write the valencies of the two elements, 2 and 1. And then the next step, we have to exchange the valency E, D, 2. Do we need to write the 1? No. We don't have to write 1 because it's understood. ED2 is the chemical formula of the compound formed between D and E. Now we will go on to the next question. Some elements exist as isotopes. What are isotopes? You know the answer. Isotopes are atoms of the same element with different mass numbers. So you have to write the same explanation. Atoms of the same element with different mass numbers. Atoms of the same element with different mass numbers are known as isotopes. What is the element denoted as D in the periodic table given below? We already identified the element as chlorine. So, D is chlorine. You have to write the name of the element, or you can write the symbol of the element. I'll write both. Chlorine, that is this. You can write the symbol or the name only. Write the standard symbol of the isotope of element D with 18 neutrons. So here we have already identified the element as chlorine. So then you can use the Cl symbol to write the standard symbol. Why? You have already identified the element. Then we can write it as Cl. First, we need to know the atomic number and the mass number. So, atomic number you can identify from the periodic table. You can count the elements, or you already remember the elements by heart. So, you know chlorine has atomic number 17. That is the 17th element. And here we need to write the isotope with 18 neutrons. So, the mass number is A. That is number of protons plus number of neutrons. Atomic number Z is 17. So, that means there are 17 protons. For mass number 17 protons and 18 neutrons, the mass number will be 35. So, when we are to write the standard symbol, it's going to be chlorine. Left hand side, top corner, we have to write the mass number 35 and the atomic number below 17. So, this is the standard symbol of chlorine, 35, 17, chlorine. Remember students, here since we have already identified the element as chlorine, when they ask for the standard symbol, we use Cl. But otherwise, you will have to write it with the symbol given to you. With these students, we have come to the end of discussion on additional questions, and we have come to the end of the discussion of the third lesson in your grade 10 science textbook, that is structure of matter. I am sure you listened to my discussion, then you studied the lesson once again. After that, you tried all these questions by yourself, and then you checked it with my discussion. So, with all that, you would have got a very good understanding about what structure of matter is, periodic table, the pattern seen in periodic table, then about metals, non-metals, metalloids, the different examples, and finally writing chemical formula. But that is not enough. You have to keep on practicing. Read the lesson again, understand and try and answer as many questions as possible, so that you are very competent to answer any questions related to this lesson.